In this video, we're going to be looking at section 8.6, which is systems of nonlinear equations. We're actually going to start with an example from 8.1, systems of linear equations. It's a little bit simpler to look at linear equations. That's why we usually start with them as an example. And then we'll review substitution and elimination, and then show how that works for nonlinear equations because it's very, very similar. Okay, so let's start with, like I said, let's start with linear equations. Let's say we have 2x minus y equals 3 and 3x plus 2y equals 8. Okay, so you should have seen something like this before. This is called a system of equations because we've got two equations that describe some sort of scenario. So we might have like revenue and profit, or cost and profit, something like that. So these two equations are kind of happening at the same time. And what we want to do is we want to find the solution, and the solution will be the x and y values that match both equations. So that means the solution is the intersection point. And to do this, we would do either substitution or elimination. If you have not seen substitution elimination before, you need to go back to 8.1 and practice some of those first. So we're just going to review that here. All right, so for substitution, you want to get one variable by itself. That means that you're looking in these equations for a variable that you can get by itself pretty easily. So this y right here would be the easiest one because all these others we would have to divide by the number in front. So this y looks the best. So let's take 2x minus y equals 3 and let's solve for y. So we're going to move the 2x to the other side. We're going to get negative y is equal to 3 minus 2x. And then we're going to multiply this whole thing by a negative 1. And we're going to get y is equal to negative 3 plus 2x. All right, so we isolate one of the letters, and then we're going to take this. We're going to take this version of y. We're going to take this y, and we're going to plug it into the other equation. It's very important that you make sure you go to the other equation, otherwise you're going to get a funky answer. All right, so let me change back to black. Okay, so we're going to put this in here. So our second equation becomes 3x plus 2 times this thing. Negative 3 plus 2x equals 8. Okay, so we make that substitution, we put that in there, and now we should just have a linear equation to solve. So it's just a matter of distributing this, moving things around. You guys know how to do this. So if we distribute the 2, we've got 3x minus 6 plus 4x equals 8. Combine the x's, move the 6 to the other side, and we get 7x is equal to 14. And I'm running out of space here, so you know I'm going to divide by 7, and we get x is equal to 2. X is equal to 2. Okay, so we did our substitution. We solved the equation. Are we done? No. Remember that the solution is an intersection point, so we need x and y. So you're going to solve for either x or y in the first step, and then you've got to remember to plug it back in. Okay, so you take this x equals 2 here, and you plug it back into either equation, or you can even use this equation right here. Any of those equations will be fine that you started with. So if we plug that back in, let's plug it into the red one right here. And plug it into this version right here. So we're going to have y is equal to negative 3 plus 2 times 2. Sorry, that's a little sloppy. Negative 3 plus 4. And we get that y is equal to 1. All right, so our intersection point is 2, 1. That is the x and y value that work in both of these equations. And you should be able to go back and check that in both equations, and it should work. Okay, so now coming back to this same problem and looking at it with elimination or addition method. You may have heard it called either one. It depends on the book that you're in. It's called elimination because you eliminate one variable, and sometimes it's called addition because you add the two equations together. Okay, so we come back to the original equations. I'm going to rewrite them here. And what we want to do is we want to add these equations together. So we're going to add the left side, add the right side, And we want one of these variables to cancel out. So if we add 2x and 3x, we're going to end up with 5x. That doesn't get rid of anything. So what we need to do is we need to get these to line up as the same number with one of them being an opposite sign. So when we add them together, they cancel out. So for this one, you could get the x's to cancel out. You can get the y's to cancel out. It's totally up to you. Since the y's already have opposite signs, it may be easier to do that one. So let's say we take the first equation and we multiply it by 2. So we're going to multiply the entire equation by 2. That's important. And we get 4x minus 2y equals 6. And we get 3x plus 2y equals 8. The second equation hasn't changed. And we're going to add these together. So we're going to add the whole left-hand side, the whole right-hand side, and of course we're going to group terms if we can. So 4x and 3x is 7x. Negative 2y and positive 2y, those cancel out, which is what we wanted. If they don't cancel out, that means you did something wrong and you've got to go back to this first step. We get 7x is equal to 14. We divide both sides by 7. And we get x is equal to 2, just like we got before. Just like we got before, we would plug it back in. So we plug it back into either equation. You want to go back to the original one, preferably not the one that you multiply by, just in case there was a problem there. So we can put it back in the first equation. We can do 2 times 2 minus y equals 3. So we've got 4 minus y is equal to 3. So subtract 4, we get negative y is equal to negative 1, multiply through by negative, and we get y is equal to 1. So our point, again, is 2, 1, just like we got before, and you can go back and check that. Okay, so this takes us through substitution and elimination or addition with a linear example. So this is the basic idea. If you need to go back and review those, 8.1 is probably a good starting point. So now in the next video, let's look at how to do this with nonlinear equations, and you'll see that it's very similar.